Salvi Balatong.
And I'm Salvi Alma Umay.
And today, I'm excited to show you how to manipulate 3D object in space using the power of math, specifically in matrix operation. And also, we use a tool and our code, a matplotlib and numpy to visualize our 3D object. Okay, let's start with our basic 3D object, an octahedron. As you can see, it's a symmetrical shape with 8 faces. How do we define this octahedron in our code? Well, it all starts with its vertices, the corner points that define its shape. This function calculates the coordinates of the 6 vertices of the octahedron. These coordinates are stored as numpy array, which is essential for the efficient matrix operation. We also define the edges of the octahedron, which are the lines connecting the vertices. This list tells us which vertices are connected to form the edges of our shape. This information is used to draw the lines that make up the octahedron. Apply transformation step by step.
First transformations is rotations. Now, let's apply our rotations. As you can see, the octahedron is rotating around the x-axis, showing the octahedron rotate 45x line in update functions. This line is create a rotation matrix we saw earlier and call the transform functions to apply it to the octahedron vertices. Second transformations is the translations. Next will be translate an octahedron, moving it into the new locations in space. These octahedrons translate 1, 0.5, 0. This line is create a translations matrix and applied it shifting to the octahedron 1 unit along the x-axis and 0.5 unit along the y-axis. Third transformation is scaling. Now, let's change the size of octahedron by scaling it. This shown the octahedron scaled 0.7, 0.7 and 0.7 and close parentheses. This line is create a scaling matrix shrinking the octahedron and to 70% of the original size of all 3 dimensions. Fourth transformations is reflection. Finally, let's reflect the octahedron across the z-axis creating a mirror image. This line shown the octahedron reflects z. This line is applied to reflect the reflections.
The final object. After showing all transformation, so as you've seen, we taken our original octahedron and through a series of matrix operations, we've rotated, translated, scaled, and reflected it to achieve a completely new position and orientation. It's important to remember that while we apply this transformation one at a time for demonstration in a real application, we would combine all these transformation into a single matrix. This is done by multiplying the individual transformation matrices together. Applying a single combined matrix is much more efficient than applying multiple individual matrices. Mathematical concepts and matrix operation used in our code. 1. Homogeneous coordinates. Imagine you want to move an object with standard coordinates. This translation is different from scaling or rotating, but what if we could treat all transformation the same way? That's where homogeneous coordinates come in. We add a port coordinate W to each vertex. In our case, we set W equal to 1. This line of code adds the W coordinates to our vertices. The important thing is that this allows us to represent translation using matrices, just like rotation and scaling. And the last one, transformation matrices. Transformation matrices. A transformation matrices is a 4 times 4 grid of numbers that encodes a specific transformation by multiplying the vertices of our object by this matrix. We can rotate, translate, scale, or even reflect it. Let's look at the rotation metrics for rotating around the x-axis. Notice that the trigonometric functions cosine and sine. The angle of rotation determines the values in these functions, which is turn determine how the object is rotated. And that's all. Thank you for watching and listening.